Hello, my name is Lokesh and this is my programming project for analysis of algorithm. In this project, I compare two algorithms that solve the closest pair of points problem, the brute force algorithm and the divide and conquer algorithm. The goal is to empirically measure the running times and compare the results to their theoretical complexities. So it begins with importing Python libraries for numerical computations, randomness and visualization. Then I generate n random distinct points in a 2D plane, ensuring that no two points have the same coordinates. So in the first algorithm, that is the brute force approach, it iterates through all possible pair of points, calculates the Euclidean distance and identifies the pair with the minimum distance. So this algorithm runs in theta n square time, following the pseudocode presented in class. So the second algorithm uses a divide and conquer strategy. It first sorts points by their coordinates, divides them into left and right halves, and recursively computes the closest paths in each half. It then checks the points near the dividing line to ensure no closer path is missed. For very small subsets, it reuses a brute force helper function. The expected running time is theta n log n. So to verify the correctness, I tested both algorithms on a small set of 4 points. So after running this code, as it seems here, both return the same pair of indices. As you can see the output, confirming they worked as expected. For experimental analysis, I measured execution time for input sizes from 10,000 to 100,000 points. Each size was tested 10 times on different random inputs, and I recorded the average runtimes for both algorithms. So as you can see the final experimental results for testing for n equal to 10,000, for n equal to 15,000, 20,000, and n equal to 25,000, and n equal to 30,000, and n equal to 35,000, and n equal to 40, 45, 50 and 55,000. So the total runtime is about 137.3 minutes, as you can see here. So after this the brute force the first after this you can see the comparison, theoretical runtime comparison between this both algorithms. So as you can see here, the next two graphs, that is the two plots, compare empirical and predicted running times for each algorithm using constants derived from the ratio of empirical to theoretical results. So to conclude this, the experimental data confirms the theoretical complexities of both algorithms. The brute force approach goes quadratically, while the divide and conquer method achieves rarely arithmetic growth. This concludes my project demonstration for the closest pair of points problem. Thank you for watching.